we're going to talk about the basics of the Smith chart. So first of all, Smith chart is this. It looks scary and intimidating, but really what it is, it's a way of graphically determining transmission line parameters much more easily than you would do it mathematically. So the Smith chart is your friend. So here, if you imagine a transmission line, you've got, this is the generator, and this whole thing is the transmission line, and this is the load. So you think about it, a typical setup, you'd have a radio transmitter, coaxial cable connecting to the antenna, generator, transmission line, load. So if you want to know whether or not or how well matched your load impedance is to the rest of the line, you can use the Smith chart to do that. Impedance is a complex number. There's R, that's the real part of the complex number, and X is the imaginary part. Okay, and you can plot impedance on a Smith chart by finding the real part and then finding the imaginary part, and where they intersect, that's the impedance on the Smith chart. And once you have the plotted Smith chart, or the plotted impedance, then you can find things like VSWR, voltage standing wave ratio, reflection coefficient, and other things as well. So here's how you do it. You normalize, you find the normalized resistive part, you find the normalized reactive part, the real part, and the imaginary part, and then you plot a point where they meet. So I'll show you how to do that. So here's my Smith chart. I'll say plotting impedance. So example. Let's see. Example. Let's say load impedance equals 50 plus J 50 ohms, and the characteristic impedance of the transmission line is 50 ohms. Let's try that. Okay, so this is the load and this is the line impedance. We want to see how well of an impedance match this is. So here we go. So here's plotting Z. The first step is we normalize. So we divide by characteristic impedance. So we just go like this. Right? Because characteristic impedance is 50, so that ends up to be 1 plus J1. So I can say that load impedance normalized is equal to 1 plus J1. So step 1 is done. Step 1 is done. Step 2, we find normalized R on the chart. Well, I have to show you a few things about this. Here's the Smith chart. The R are the numbers along here. And the X are the numbers along here and down here. So if the step is, if we have to find the normalized R, what did we work that out to be? That's 1. So this is the normalized R, this one is the normalized X. So finding the normalized R, which is 1, I go along here, these are the R values, 1 is right here. Okay, so that's 1. That means everywhere on this line that passes through 1, that's a normalized R of 1 on that circle. So we could say anywhere on this circle, normalized R equals 1. Okay? Now, next step is find normalized X on the chart. Well, that's these numbers here. And since it's plus Jx, it's going to be the top half. If it was minus Jx, it would be the bottom half. So I go along here, that's 0.1, 0.2, 0.3, 0.4, I look and I see 1. There's 1. So everywhere along this semicircle, okay, so that's in the wrong place. Normalized R equals 1 is everywhere on this circle, and normalized X equals 1 plus 1 is everywhere on here. And the next step, so we have the normalized R of 1 and the normalized X of 1. Where they cross, you can call that load impedance. So we just plotted, so normalized impedance is 1 plus J1, and you could say the impedance is 50 plus J50. 50 ohms. That's 50 plus J 50 ohms plotted right there. So that's plotting impedance. So do one more, and then you will be an expert. So load impedance is equal to 300 minus J 25 ohms. And you can say if Z naught, which is the characteristic impedance, is equal to 50 ohms, the normalized impedance is going to be 300 over 50 minus J 25 over 50. And that's going to be 300 divided by 50. What's that? 300 divided by 50? 6. 6 minus J 25 over 50. I think you know what this is. 0.5. Okay, it's J 0.5. So we were looking for 6 minus J 0.5. This one is the normalized resistance. This is the normalized reactance. We have to find this first, and there will be a circle associated with that. We find this, there will be a semicircle associated with that, where they cross. So you have the circle, and then you have the semicircle where they cross. That will be the load impedance, just like before. So I'll get a new one. New Smith chart, 6 minus J 0.5. So here we go. So what is our Z equals 300 minus J 25 ohms, and characteristic impedance of 50 ohms. So 6. So remember the resistive part is along here. Normalized resistance is 6. That's 3, 4, 5. This happens to be 6 right here. That means this circle is the circle of normalized R equals 6. And then we want minus J 0.5. So these are the numbers for reactance. 0.5 is here, so I just trace that semicircle up here. The numbers are also here, they're the same numbers. Keep going, and we keep going, we keep going, we keep going, we keep going. That is going to be the load impedance right there. A load impedance of 300 minus J 25 on a 50 ohm line. So that's how you plot impedance on a Smith chart.